Good morning. Hi. I want to talk about fractions a little bit with you and maybe give you some inspiration for a teach back assignment kind of thing. Let's see. I just wanted to show you if I were working with young children, you're probably going to hear my dog. She wants attention too. And I were trying to explain or trying to help them understand an initial concept of fractions. Before you even talk about numbers when they're little, you might want to use some kind of shapes. I have different kinds of shapes that I use here. And let's say, for example, we wanted to talk about the shape of a rectangle. And I were to say, this is one building I made. And I said, I have one whole rectangle. Here's my one whole rectangle. And I've covered it up with parts to cover it up to make one whole house or something like that. And let's say I had one whole house and then I had an extra 1/4 of my house. What does that mean, 1/4? Well, if I were to break my house in half and half again, that's a fourth. So I might start saying this is a 1/4 of my house. Maybe you wouldn't, but maybe they could visually kind of get the feel of that. You need 4 of these to make that house or that rectangle. And let's say I had 1 1/4, and then someone gave me 5 more of those fourths. 1, 2, 3, 4, 5. I might wonder, well, what is that when I put it all together? How many houses could I make out of that? 1 1/4 plus 5 more fourths. I might say, well, let me see, I can make more out of that. I can make 1, 2, 3, 4 parts make another rectangle, or maybe whatever you're building with kids. And then you have 2 more left over. So adding fractions starts like that, like just matching shapes up, breaking them down. Let's say, for example, we wanted to look at these circles here. And in these circles, first I might establish what one is, one whole circle. And if I had 2/3 of my circle, so that means I break it into 3 parts. 1, 2, 3. If I had 2/3 of my circle, and I had someone say, hey, I have these 2 little pieces. How many of these make a circle? 1, 2, 3, 4, 5, 6. Sixths. These would be sixths of a circle. If someone gave me 2 of those, and I added it to what I already had, 2/3 of a circle, what could I do with that? Well, I could fit it in here, and actually 2 of those sixths is the same size as one of these thirds, and I can make one whole circle with that. So that kind of concept you can kind of play around with by just letting kids play with all of these manipulatives and make some pretty patterns. They might like to make my daughters used to like to make some flowers with their pretty patterns. They always made these flowers like this. And if we looked at this flower, I might say, well, that's one flower. So one whole thing could be anything. It could be a rectangle, it could be a circle, it could be a flower. And I might ask, well, how many parts make this flower? How many petals do I have? 1, 2, 3, 4, 5, 6, 7, 8. I need 8 of them. So 8 out of 8 makes one whole flower. But if I only had 7 out of 8, I wouldn't have a whole flower, would I? I would need another one. I would need one more eighth back to make a whole flower. And then kids, I wouldn't use fractions with young children in numeric form, but I would say, something like, what if you had only 1, 2, 3, 4, 5, and I gave you, let's see, 7 more. So I take one of these out. That leaves me with 1, 2, 3, 4, 5, 6, 7 out of 8. So if I take 7 out of 8 and I add it to 5 out of 8, can I make flowers out of that? What can I make out of that? And then the kids just might play around and say, well, let's see. I can put this together and get a whole flower. So I get a whole, a unit of whatever it is I was trying to make. And I have more. And I might say, I have 1, 2, 3, 4 out of 8 left. So I have 5/8 plus 7/8 more gives me one whole and 4/8 left. And then if I play around with that 4/8, I might realize that that's half of a flower. So it would equal 1.5 of the flowers. Things like that we could do with kids just to kind of play around with numbers. And you can use anything. You can even use licorice. I gave you a really tough problem to work on today, and in the teach back, I gave you something with 7/12. So if you were doing 7/12, you might want to, just find out what is 12ths. So I actually took scissors here, and I said, well, let's use a licorice stick as one whole unit, and let's cut it up into 12ths. To do that, well, first, I think I'd cut it in half, and that might be a good thing to talk about. That's a half, and a half makes a whole. And then if I want to get the 12ths, well, gosh, I'm going to have to maybe break them in half again. If I break them in half again, now I get 1, 2, 3, 4. I get 4 parts. So now I have broken it into fourths. But to demonstrate a fraction that has 7/12ths, I'd have to break it further into 12ths. So I might cut another one down, or keep cutting it down until I had 12ths. I'd have 1, 2, 3, 4, 5, 6. They didn't come out very even. 7, 8, 9. Each of these is thirds. Yeah, 10, 11, 12. So if you take each of your fourths and cut them into thirds, then you have 12. So one whole licorice stick is the same as 12. They have manipulatives they make for classrooms that you don't have to use food, but not everybody has that. So you can certainly make them with just paper or anything around you, string. But the concept is they need to know the concept of a unit first. So what is the unit? What are we breaking into parts? And that unit would be, in this case, it's one whole licorice stick. That's my one unit. If I wanted to show or demonstrate a subtraction here of 3 and 7/12ths, then I would show my 3 whole licorice sticks, and then I need 7/12ths. So it'd be 1, 2, 3, 4, 5, 6, 7/12ths. So I'm taking away 8, 9, 10, 11, 12. I'm taking away 5 of them, and that just creates this number, 3 and 7/12ths. So if someone were to say, I have 3 and 7/12ths, and I'm going to give away or take away 2 and a third, taking away the 2 is easy, but we'd have to start with the fraction. Can we take that fraction of 1/3 away from 7/12ths? What was a third? When we had broken into fourths, we had 3 pieces were a fourth. So 4 pieces are a third, right? 4 pieces are a third. 4 pieces are a third. 4. So 1 times 4 is 4. 3 times 4 is 12. 4 pieces out of 12 is the same as 1 out of 3. So if I'm doing this subtraction, 7/12ths, my 7/12ths, take away 4/12ths. 1, 2, 3, 4. I didn't have to cut up any more licorice. I just had to take away my 4/12ths and my whole number 2. So I'm taking that away. So in other words, I started with 3 and 7/12ths, take away 2 and 1/3, which is the same as 4/12ths. What do I have left? I have 1 whole, and I have 3/12ths left. So I could answer my question that way. 1 and 3/12ths left. 3/12ths, so that was the same as 1/4, wasn't it, when I cut it in fourths? So 1 and 1/4. I better double check my math before I post this, but this is just a kind of a manipulative type of problems that you can do with kids. You can just cut up